Hello, this is Nazmul Simab and you are watching Gateway Solution. In this video, I am going to solve a lead code question and question is valid mountain and question based on array. Question goes like this: given an array of integer ARR, return true if and only if it is a valid mountain. So we have to understand that what is valid mountain. For being valid mountain, first of all, the length of array should be greater than equal to 3 and it should strictly increasing till it reach the peak, and after reaching peak it has to strictly decrease. So this is the condition for being valid mountain. Now we'll see in whiteboard how we'll approach toward this question. First of all, we have to understand what is valid mountain. Again, I will explain you for more crystal clear information about question. So mountain is something like this and it should have some peak, and all the element at right of the peak should be in decreasing order, and again from here it should be in decreasing order. So if we go in some direction, suppose from left to right we are going, so when we go left to right, first all the element will keep increasing after reaching certain peak, and then all the element will keep decreasing. So we have to find some max value, and till where all the element exist in right will exist in left will keep increasing, and all the element exist in right will keep decreasing if we go in one particular direction. So now I will take one valid mountain. First of all, let's understand why we need mountain whose length should be greater than or equal to, why we need an array whose length should be greater than or equal to 3. Suppose if we have array length as 3, then we have some element 0, 3 and 1. So from here we will go, we will reach 3, and from here we will go and we will reach 1. So this is a valid mountain. So array length should be at least 3. If we have array something like this, we have two element 0 and 1, we will reach the peak, but how we will come down, no one knows. So 2 is not valid. So we need array whose length should be greater than 3. So in our pseudo code, first thing should be, here is pseudo code, and our pseudo code first thing should be, it should be greater than. If array will be less than 3, then what we will do, simply return false. Means mountain is not possible. How we will judge it is a valid or not? Okay. So if array length will be less than 3, we will simply return false. If array length more than 3, then we will decide something. Suppose we have array here 0, 1, 3, 2, minus 1. If you see in this array, we are going at peak, and after that we are going down. So it is a valid mountain. And how we will do, how we will check it programmatically? What we will do, we will try a 2-pointer approach, which is the best approach for this question. Our first pointer, we will consider it as left pointer, and our second pointer, right pointer. And we will initialize our left pointer with 0 and right pointer with n-1, which means that element at last index. I will give index also 0, 1, 2, 3 and 4, which means right pointer will be at 4. And what we will do, we will check if the next element is greater than the previous element in left pointer, then we will increase our left pointer. And we will keep doing this. When we will find that next element is not greater than the previous element, then we will stop here. We will break out the loop. Our loop will break out. And similarly, we will decrement right pointer by checking that if the previous element is greater than the element at next position. So in this way, we will check. The condition will be something like this: while L is less than the length of this array, let's tell it as n, length of this array, while L is less than n-1, we will loop this, and another condition should be, and then ARR of L should be less than ARR of L plus 1. Since we are using here L plus 1, we have to give condition while L plus 1 less than L, because we don't want to go with array index out of bound exception. And what we will do, we will increment. And similarly for this right pointer, we will again do a while loop, and these two while loop are not nested while loop. It is an independent while loop, so time complexity is not going to increase. It is going to be big O of n only. So what we will do with right pointer, if r greater than equal to 0, then what we will do, ARR of r minus 1 should be greater than ARR of r, right? These are the things we are going to do, and what we will do with our decrement. And at last, if both pointer, if suppose this pointer decremented once and again decremented once and reach 3, and by checking next element which is smaller, not greater, so it will stop here. Similarly, left pointer also go, it will get incremented when it check that first element, next element is greater, then it will again check next element is greater, then again incremented, and then it will again check, but it is not greater, so it will stop here. So if you see at this particular moment, L at this particular time, L and R both are pointing same index. So if L or R, if here if L equal to R, if this will true, it will obvious this expression will, if L equal to R, this expression is going to return true. If it will point somewhere else, if left will come here and right will come here, which basically means that this mountain is not a valid mountain. So in this case, what we are going to do after doing this whole thing, we are going to return, we are not going to return true or false. We are directly going to return L equal to R. This is the best way, I think, because if we will not write this particular statement and we want to go in some other way, we have to do something like this. If L equal to R, then return true, which is, I think, not good code, unnecessary line of code. Else return false. This whole line we can compact it to this. So this is the code. Hopefully you understood. This is a two-pointer method. We have to increment pointer once we find a greater element from left, and we have to decrement pointer once we find a greater element from right. So now I will try to implement this code, and we will see how. Now I will directly write the code here. Int, let's give it name as L and initialize it with 0. And next element is going to be R, which is right pointer. And it will initialize it with n-1, in this case arr.length -1. And what our first condition will be, our if arr.length is going to be less than 3, then what we will do, simple, return false. We don't want to proceed with this like if array length is less than 3, so doing any calculation is waste of time. Simply return false. If array length is greater than 3, then we will do loop over it, and we will check. First of all, what we will do, while L is less than arr.length -1, and then arr of L should be less than arr of L plus 1, right? And what we have to do again, we have to give condition L plus 1 should be less than arr of length -1, because we will get array index out of bound exception if we will not do this. So if this condition become true, then what we have to do, we have to do nothing, simply increment L plus plus, and we will give again another while loop, and this time we are going to check R -1. I will do this later. R should be greater than equal to 0, and what we have to check, arr of R -1 should be greater than arr of R, and this is the condition we have to check. And since we are using R -1, so we have to give condition here, R -1 should be greater than equal to 0, and what we will do in case of R, decrement it, so that we are going toward a loop break condition. And after that, we are going to return R equal to L, which means that we are checking that is R equal to L. If R is equal to L, then return true, else false. This one statement means all those things. So I will try to run the code. Hopefully we will get the output. Where is arr.length? Yeah, I missed the dot. Again, run the code. Yeah, we are getting expected output. Now I will try to submit, and let's see. So here we are getting error in this particular input. We can analyze error also. If you see that it is strictly, if you see from right side, it is strictly increasing, and from left side, it is strictly decreasing. So what will happen? The main thing is that when you go from the right side, this will decrement, and then it will become -1, and again decrement, and R will become 0. And of course, our L is 0, so R equal to L, so it is going to become true. And we have, for avoiding this condition, we can do two things. First thing is that we will give that if R not equal to 0. If R becomes 0, then we don't want this. Okay, so now we will try to submit this solution. Hopefully it will work. That got accepted, and our solution is 100% of Java Online Submission for faster than 100% of Java Online Submission for valid mountain. So this is great, and we can do one thing, other thing also. Instead of mentioning it here, we will decrement our value till 1 only, not 0, so that we will get a proper output. Hopefully you got this, what I have done here. I didn't reach till 0th index. I went through till 1 index, and if we reach till 1 index, we understood that next is going to be 0. So hopefully it will work. I'll try to submit. Yeah, again it got accepted. So these are the ways in which we can come out with the error. So don't get offended or something like with the error. It happens, and hopefully you will consider sharing and subscribing. Thank you. Bye guys.